Hi everybody, here's a fun little project I've been working on and I thought I would share it with you. In the last video, I believe, I was working on an amplifier out of a Hammond M3 organ. And one of the things that the owner of this organ wanted to do was he wanted to be able to connect his mixing board or his, for his PA system directly to the organ without using a microphone on the speaker. Now, typically the M3 does not come with a line level output, and there's a lot of mods out there that are well documented for modifying the amplifier to be able to do this. One of the easiest things is to come out of one of the voltage amplifier sections, in the amplifier, and kind of put a little isolation capacitor on there, and you can drive it directly from there. But I wanted to, of course, me being the one that likes to tinker around, I wanted to see if I could make something where we could disconnect the speaker and use the signal that would normally drive the speaker to create a line level signal that's representative of the amplifier as a whole. What do I mean by that? Well, whenever you drive an amplifier into a speaker, the power amplifier section and the speaker itself, the load, contributes to the sound. Now, I'm not talking about just, audio amplifiers where you would listen to music, but more importantly, I'm talking about amplifiers that are used for musical instruments. I did a couple of videos with guitar amplifiers, and in all of those I mentioned the fact that I believe a guitar amplifier is every bit as much of an instrument as the guitar that you're plugging into it, because it radically can affect the tone and the sound of the guitar and of how you play it. So therefore, we want to try to capture that. One of the signature sounds of a Hammond organ is that distortion, that kind of that gritty sound that you get when you overdrive the amplifier of the organ. That's where you get that kind of signature rock and roll Hammond sound. And so I want to be able to pick up those output tubes, those 6V6s, kind of going into breakup when you turn the volume up and so forth. But I want to do it in such a way that we don't have to have the speaker connected, where we can control the volume going to the PA system. And the best way to do that is to convert that into a line level signal. Now, any of you that have worked with guitar amplifiers in the past, you may have heard of a device called a power soak. And I think one of the early ones was made by Tom Schultz of Boston. And quite frankly, I think that device was a complete flop, if I recall, in its day. And even if implemented incorrectly, using something like that can even damage your valuable guitar amplifier. Essentially, all it was a network of power resistors, and they would just connect them in place of the speaker. And that would allow you to the resistors would absorb some of the power, and then it would reduce the amount of output. The problem is a resistor is just that. It is a resistive load. It does not have reactance like a speaker does. That's got two problems with it. Number one, you no longer have the effect that the speaker itself gives to the sound. It's very important. But also, you don't have the reactive component that you're presenting to the amplifier output. That also affects the sound, but more importantly, it can also affect, especially in vacuum tube amplifiers, it can affect the surge current and so forth of the output tubes. And in some cases, if you don't use the correct loading and so forth, you can even damage the amplifier by using them. So they kind of fell out of favor. Now, there have been other ones people have experimented with over the years with reactive loads and so forth. And I didn't want to get anything that crazy. So, all of that being said, I've decided I'm going to use a resistive load. I'm going to try to I tried to make it so that it would be compatible with an organ amplifier, like a Hammond Spinet organ amplifier like the M3, so that it won't damage the amplifier, but in the same token it can somewhat capture some of the character of the output section, so the output transformer, the power tubes, and so forth, so that when we drive those output tubes into clipping, we can actually capture that with this little device. Now, me not wanting to get too far into the weeds designing things from scratch, I looked around and decided to use a circuit that I've already designed and used previously, and that I have some extra boards. And that's namely this over here, which is my little buffer preamp project. Now, when I had these boards printed, I printed several of them, so I had some extras. And so that's part of the reason that the design is the way it is. If you were going to design something from the ground up, you probably wouldn't want to do this, because this is going to be a little bit of a Rube Goldberg machine for getting a line level out. But actually it worked out really well, because there's some features on it that I really like. Number one, this is 2-channel. So even though the M3 organ is a mono device, I can split that into 2 separate channels and have 2 outputs to drive a stereo sound system. So you can connect this to, your home stereo, the auxiliary inputs, or you could drive through XLR, you can drive a regular commercial mixing console. And that's another thing I like about this, is it has the circuitry built onto it to convert the unbalanced output to a balanced XLR output. So it's kind of got all the things I want. We also have adjustable gain for the preamp stage and adjustable volume, and we can play around with the values on this board to possibly, if we want to change things ourselves, we can add or subtract gain from the preamp and so forth. The other thing is this preamp will give isolation between the speaker terminals, which is right here, and the output, which is right there. And we can do things. We might be able to modify this in some way to kind of change the phase relationship between the right channel and left channel, make one lead or lags ever so slightly to give kind of a wide effect or a simulated stereo effect. So there's lots of things you can do with this once you start playing around with it. So that's what I did. I built this. This is just a trial run, and well, it works. So I'll give you a little demo. So you can hear it plays. It works really well. It sounds good. It's quiet. So what are we doing here? Well, we're implementing the help of our little Lafayette LA950. This is just a little cheap stereo amplifier from the 1970s. And we're driving it directly, one of the channels of this, directly into the input here. So this is your speaker input terminals. And then it's converting it to the line level output. And we're feeding that into our little SMSL Class D amplifier and into our little homemade speakers. You've seen those before. So essentially you're taking a speaker level signal, converting it to a line level signal, and then driving your stereo with it. That's what I'm doing. Now that you have an idea of what this is, let's take it apart, and we'll go over the circuit first, and then we'll take this apart and you can kind of see the assembly, how it went. And then probably down the road somewhere we will connect this to the organ and to the PA system, and we'll see what kind of effect we can get out of it. All right, briefly, here is our quick overview of the schematic. I'm not going to review this because if you go back to my buffer preamp project, this is the same schematic. It really hasn't changed. And I explain this in detail on that. Now, just a couple notes about it is, if you look here, you have your feedback resistors. This is set for unity gain. See, we got all 10K resistors. We can change the values of this, and we can change the value of this, and we can change the gain of these two stages if we wanted to. So if we wanted to be able to cause this to drive into it, have its own little built-in overdrive or something, we could do things like that to kind of cause it to go into clipping or whatever. Or if we need a higher gain or whatever, we can do that. The RIAA section, you don't even have to populate the board with that if you don't want to, because we actually, in this one, I just bypassed all of this. I think the one in there does have the components on it, but we're not using them. Again, this would be if you wanted to be able to drive this into a phono stage of a stereo. We never really have the need to do that on this. So we don't even need to put these components right here in. But a little bit more is, the original design did not have these extra chips on it down here, nor did it have these extra outputs. And what that is our balanced to XLR adapter circuit. And all it is 2 voltage followers. One is an inverting one and one is a non-inverting one. So you can see the non-inverting one comes in here. It then feeds the inverting voltage amplifier or voltage follower. And again, a voltage follower is just that. Whatever you put on the input is what you'll get on the output. So there's no gain or anything in this circuit. We're really just buffering the circuit, number one. And number two, we're getting the 2 out-of-phase signals to give us our balanced output. So with respect to the common, this one will be positive going while this one is negative going. Okay, and again, I'm not going to get into how XLR and how balanced circuits work. You can look that up. There's so many people have done this already. But this circuit is right on here. So everything we need is right on this little board. Now, a couple of notes before we take this thing apart, because I know I'm going to get comments. Number one, you do not have to do all this just to get a speaker terminal to go into a line level input, let's say, for instance. You can do something as simple as a simple resistor divider network. That's total simplicity. Or you can go all the way up to total Rube Goldberg, even beyond what I did here. The reason I'm doing this is, number one, because I wanted to experiment with it. Number two, I already had the circuit board with this circuit designed already, so that saved me a lot of time and effort. And number three, I wanted the versatility of trying some different things. This may be something that I may want to try as a guitar effect at some point in time. Again, being able to capture something at the speaker terminals without actually, overdriving a physical speaker is desirable in some ways. You will never be able to totally do that, but you can. I'm thinking we can get some pretty neat little effects and sounds by playing around with a similar circuit to this, I should say, not this exact circuit, but different variations of it as I hit the camera. So this is an experiment, totally. Okay, don't go saying that this is stupid and it doesn't make sense and you could do it this way, that way, or the other way. You're 100% right. There's a trillion ways you could probably design something like this. I'm doing this one because it was easy and because it's versatile for what I want to do. That said, let's take a look. So here's our board, and it's populated, you can see. And all I really did was put the components on the board. Couple things: you do not need, like I said, to populate the RIAA stage. I may reuse this board someday for something, I don't know, but those few extra components are on the board. Second of all, instead of a 7809 and a 7909 for a 9-volt rail, this one I fitted a couple of 12-volt rails, or 12-volt regulators, so this actually has plus and minus 12 volts, which is just fine for the NE5532s that we're using in here. And the other thing is, you know, original, like Texas Instruments authentic NE5532s are not super expensive, and they are pretty good performing little op amps for what they are. There's lots of different op amps out there you can use that'll drop in replacements. Some are much better spec, some are not as good a spec, but for the price and for the performance, I like these. I use them a lot. Now you can see that we just hardwired in the connectors for the XLR, for the RCAs, and here's the speaker terminal, and it goes down into this little resistor network. Now I have two 4 ohm 100 watt resistors in series, so that gives us an 8 ohm dummy load. The speaker load recommended for that organ amplifier is 8 ohms. That's why I did this. That amplifier only puts out a maximum of probably 10 or 12 watts. You're not going to get any more out of that dinky little output transformer and those two little 6v6 tubes. So this is going to be way overkill, which I want, because then this won't be running really, really hot. The signal is actually being tapped off of this little voltage divider that is shunted across, in parallel, I should say, with the 8 ohm load. And it is high impedance. And then it comes out into these two little, what are they, 100 ohm or 150 ohm, 100 ohm resistors. And it splits off to your right and left channels. That's what the purple and the white wires are. And that's how we're getting our stereo. Now we can play around in here with some other things, possibly, to make some differences between right and left channel to give you a little bit of a stereo effect. Down the road, I may decide to try something like that in a future project. Don't know yet. Put it on the huge list of things that I hope I'll get to someday. Power supply is simple. It's all on the board, and really the only external component for that is going to be your power transformer, which this is one I had. This is I think this is like a doorbell transformer, 24 volts. So it's overkill because it's a 30 VA transformer. You don't need anything nearly that big for this little tiny circuit. But again, this is all about what you have in stock that you can put together. A little fuse holder, just in case something goes wrong. And that's really all there is to the circuit. Now, during the build process of this whole thing, I stopped in a few places and recorded some of it. So I'll kind of stick those little clips in here, and so it's not going to be real well organized or so forth, but I'll put those couple little clips up, and just to give you something to watch, and so you can kind of get an idea of how I tested this out after I put it together and built the board. We kind of tested it on the bench without putting it together first, just to see how the XLR works and a few things like that. I'll share that with you, and then we'll finish up this video. Right, we have the board populated, as we saw, with the components, and I have just the XLR adapter circuit connected right now. The way this board is laid out is these little white wires here will connect to the output of our buffer preamp. So this right here, these would go out to just your unbalanced outputs, like your RCA output. And if we want to use XLR or balanced output, then we would connect that white wire to this point. And we can actually put a switch in there when we build this up to do that. But really, for right now, because this is an untested circuit, I just kind of squeezed this extra circuitry on the board and kind of had a couple of them printed. I just wanted to make sure that it works. So I'm just feeding a signal right into here, and then into these two voltage followers. One is inverting and one is non-inverting, as we discussed. And we're just looking at the output with the scope. So we're going to look at channel 1, the positive, and channel 2 is the negative with respect to the common. So there's our probes, and let's go up to the scope. And if we look at the oscilloscope, this is what we see. They're identical signals, and they should be 180 degrees out of phase from one another, and there they are, just like that. Now, If I invert one channel and then add, we should have that. And you can see they should be additive. So now you're looking at the actual differential signal. So reading from positive to negative, and we're now ignoring the common, you get the two signals added together. And that's what it should be. All right. If I uninvert the one channel, they should cancel each other out, and they do. So that tells us that our BNC, or I'm sorry, our RCA to XLR adapter is working, and our 2 voltage follower circuits are working properly, and we can go ahead and put this thing together now. Okay, I have the whole thing wired up here, and as you can see, well, you can't see because it's off the camera a little bit, I have the scope connected to the XLR outputs, to the positive, negative, and common, or the plus, minus, and common, however you want to word it. And we're now going into the buffer amp. So if we look at the schematic here, we're going into the inputs like we normally would. And I'm driving a 4-volt peak-to-peak 1 kilohertz signal, sine wave, into one of the channels. And here is the output that we're getting. And it looks really good. And if I switch to channel 2, again, it's 4 volts peak-to-peak. If I chop the channels and look at both, you can see that they're 180 degrees out of phase. And it looks good. And if I add and invert, they add together. So we're all set. So what we can do is we can just use channel 1, or just use the positive to the common, and we can use that for an unbalanced output, and that'll just go to just a single RCA jack. And then if I use all 3 terminals, the positive, negative, and common, we can connect it up to the XLR jack, and I have a couple of those. Now I'm pretty sure I have the Gerber files and so forth, and the schematic for this board posted up on Patreon. So my patrons can actually download that if they want. We're just probably going to leave this right here. You heard it work. It does function. And I think my next thing is when my neighbor gets the organ finished and playing properly and get it working in its original stock condition, then we will experiment with this box and see what kind of effects we can get, and see how well this works connecting to his PA system, and see if we can actually have something that he can use to record from and so forth. So that's going to be it for right now. It may be a while before I get back around to this. I have another long project that I'm going to start right after this video. It's going to be a multi-part series, and I'm hoping some of you will like it. I know I plan on having a lot of fun doing it, so hopefully you can look over my shoulder and have a little bit of fun watching it and playing along. All right, until then, as always, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you again real soon. Take care. Bye-bye.